Thank you everyone for joining today. My name is Joe Henderson and I'm the General Manager of Edrans North America, based here in Portland, Oregon. We have with me Paul Jane from our cloud engineering team out of Barcelona. And this installment of our Tech Talk series, today we'll be diving deep into one of the pillars of the AWS well-architected framework, security, and specifically talking about identity management at scale using the tool Okta. Some guidelines before we start. This talk will be about 30 minutes in length and all attendees are on listen only. However, we do have the questions feature open in the chat, so feel free to type in any questions as we go along, and we'll do our best to get to all of them as time permits. So let's get started. First, a little bit about us. We are a premier AWS consulting partner. We've been around for a little over 10 years and have over 100 engineers across offices here in Portland, Oregon, Barcelona, Spain, and Buenos Aires. As an AWS Premier Consulting Partner, we have competencies in migration, DevOps, managed services, and more. We're also a part of the AWS Well-Architected program. A central part of our business is cloud strategy, where we help customers adopt, optimize, and innovate in the cloud, as well as provide managed services, helping customers run their AWS infrastructure 24/7. Additionally, we offer software development services, where we help build cloud-native applications and AI and machine learning solutions. So, with that, I will pass it over to Paul.
Thanks, Joe. Hi, everyone. It's Paul from Cloud Engineering Department in Barcelona, and this talk is about the best practices that we learned and applied over the last year with some customers with large corporate environments. All of this in order to preserve an environment where the hierarchy of users and groups, as well as the permissions assigned to them, comply with the highest standards of security and flexibility. Security, because we will use an identity provider such as Okta that offers many practical functions for companies of all kinds, from small or medium-sized companies to large corporations. The flexibility, mainly to have an environment adaptable to sudden changes of any kind that affect the entire organization globally. Let's say, for example, that HR department decides to change the name of all the departments or just restructure all the entire company. So what side effects will have in IT departments that change? Also, this talk comes to present the advantages and best ways to manage multiple cloud environments, in our case only in AWS for the purpose of this demo, or corporate infrastructures as far as centralized authentication and access management are concerned. All this by adding a nice automation layer with a HashiCorp product called Terraform, that allows us to automate the entire creation of an infrastructure in the form of code and on a large scale also, thus being able to maintain it safely and following all the best practices of the infrastructure as code. Okay, so this is going to be our journey today. I'm going to start talking about knowing our environment and how important it is to follow best practices and avoid the bad and toxic ones. How we manage the users and groups in an efficient way and thinking in future possible scenarios. In this first part, I'm going to introduce a few features on Okta that helped us in the past to solve this kind of organizational problems and how to do it by being compliant with the most high resiliency, efficiency, and security standards. On the second chapter, we're going to talk about how can we automate all this by focusing on using Terraform and some nice ways to work with it that can help you to manage dozens of technicians managing your infrastructure without colliding with each other and or losing any data. And finally, we're going to get a little bit more technical and deep dive into Terraform's code and Okta API to retrieve some useful information, and that might be useful, for example, in a migration. So here we go. I wanted to start explaining how AWS well-architected framework recommends to use AWS Organizations, an AWS account management service that enables you to consolidate multiple AWS accounts into an organization that you create and centrally manage. This way, we're able to create a root account and make all the other AWS accounts childs of the main one, classifying them in what it's called organizational units or OUs. Inside these OUs or AWS sub-accounts, we can have one or more environments spread all across the whole hierarchy. This allows us, for example, to acquire other companies or simply manage them under the root account. This way we can separate production environments from staging or development ones and create blueprints to create more environments to be used as templates. So every new account that is created can be automatically configured with a permission setup and many other resources enabled and already configured by default. This is another view on how the permissions on those organizational units or accounts can be assigned. With this approach, we can enable some resources on some environments and deny the ones we don't want to be accessible, modified, or deleted. For instance, we can log with CloudTrail all the events on all our environments and set it somewhere just to analyze. And to accomplish that, we're going to disable permissions on CloudTrail for the organizational units under the root account. With this change, nobody under the root account should be able to disable CloudTrail on those accounts. The first thing to think about when you're going to use a product like Okta, especially in large corporate environments, is how you're going to manage and organize all your users, groups, and departments. Most companies delegate this task to Okta. Some of them just prefer to have their on-premises Active Directory or LDAP as a source of truth, and that depends on every case and company. But in order to maintain a good data consistency and avoid human error, I just recommend to don't do it by hand. Why not automate it if it's possible, right? Okta provides several methods to import your users into the platform. You can use, for example, Open LDAP as your source of truth. You can use Active Directory. You can even use Okta as your own LDAP service or Active Directory. You can import also the users on a CSV file. You can import those users from any HCM software. You can do it just using Terraform, as we are going to see in our demo today, and also by doing calls on the REST API with your preferred programming language. So when it comes to organize users, the most simple approach, if you have just a few users to manage, is just to assign the applications to users. With this approach, every user, depending on its role, will have access to one or more applications, but that's not quite suitable when the number of users grows up exponentially. In this case, we define the users in the next way. We assign the users to groups, as normally we do, and those groups are assigned to the proper applications. I will advise against make manual assignments, because then we're probably going to end up with legacy users with legacy permissions, and that will generate, on the one hand, potential security issues, and on the other, losing control of managing users in a semi-automated way. For example, classifying users into the groups. This is another way to show this. If we manually assign users to applications, the permissions and configuration settings assigned to that user for the application tree, as you can see, will be out of control, and they will not belong to any group. So we won't be able, for example, to extract lists of who have access where, or at least not in an easy or a fast way. So we rejected to use this approach. Instead, we create another group called Group A Admins and assign this group to the application with the proper permissions. The problem in this case is that there was a constant flow of people entering and leaving the company, making this task harder and harder to manage across the time for the business integration team. At that point, we realized that it would be great to automate all the onboarding process by using Terraform or some kind of automation tool, for example. This way, we can have backups of all the infrastructure, all the changes reflected in a code repository, and every change can be a small change that can be made every time enable technicians to test everything. But the fusion of our customer with this large corporation group and its Okta tenant was imminent, so we contacted the corporate group tech department and we agreed to define and use some standards when it comes to assign applications to users, like prefixes and suffixes, naming conventions, and so on. One of these standards was to take advantage of a nice feature offered by Okta, the group rules. These rules allows you to create conditions that when they are met, the user is assigned to the groups we define. The most easy way in our case was to use the user attributes in every user profile, like for example the department where the user belongs to. This value usually comes from the HSM software from HR department. When a new employee joins the company, it is automatically added and enabled in Okta as part of the fully automated onboarding process. The department field can take many values, and depending on your case, Okta offers you a set of conditions and operators, even some type of Okta regular expressions to do it, where you can check, for example, if the attribute value equals, starts with, ends with, or just contains some string. So group rules, as you can see, become very handy when it comes to assign automatically applications to users when they are created in Okta, especially in the onboarding process. As best practices for the group rules, just review your existing rules to prevent duplicate conditions. It's not going to help you if you have duplicate conditions. And most important, I think, just avoid as much as possible to have cascading rules. There's no point. It's better to create one rule for each case. It's going to simplify our life. Then preview your rules on a test user, a dummy user, or a testing or development account when possible. Nobody wants to do experiments on production. And for service accounts, for example, those TV screens we hang on the walls showing dashboards, even these dashboards should be protected with access credentials to be security compliant, and to do so, we created a group for them. Then created a policy that applies only to this group, which says basically all users from this group do not need to provide a second factor authentication method. In one hand, it solves the problem, but at the same time it creates a potential security issue. Let's take for example that one user forgot his phone at home or it got just stolen. When this employee goes to the office, he reports the incident, and while he gets a new phone, his multi-factor authentication method can be either changed by another one, for example SMS, email, or an RSA key, or just disabled. But who do this? And whoever is doing this, will he remember to erase the user from the avoid two-factor authentication group? To solve this, we just created another group and another policy to don't mix service account with incidents with phones or two-factor authentication devices. And for the potential forgetting about removing the user on that group, we just created a solution with some Lambda functions and a DynamoDB table that automatically remove users from this group after several hours and notify it via Slack. If the user needs to be added again for more time for any reason, he must be added by hand. This way, there's no possibility of that user remaining in that group, creating a potential security issue. If you're gonna work with a large number of users and applications, just don't do individual assignments. Instead, you can assign users to groups that have applications assigned to them. Follow as much as possible always the less privileged principle, and since Okta still does not support tagging resources, use proper naming conventions and prefixes to filter results and automate things faster. Remember to disable two-factor authentication for service accounts and use when possible group rules. But if you need to do a migration, there's a few questions you should ask yourself. For example, how is the company organized and how we want to be organized in the future? And that will require probably many people involved in the process. Who should have access to what? Another daily topic probably to be discussed by your security department. There's a frequent rotation of people between departments and squads. If a lot of people comes in and out of the company, are we 100% sure that when they leave they cannot access the company resources anymore? What happens, for example, with Google Drive documents? And this takes us to the next question. Who assigns permissions and adds the new employee account in all the software services? Do we have Onboarding process, do we need it? Do we have auto-provisioning and deprovisioning for accounts? What will happen, for example, if we have to migrate all this? Are we prepared for that? And do we have a security incident response procedure? What will happen, for example, if an account or the company gets compromised? We've been talking about users, but what about permissions and roles? Some applications just give us access to the application itself, but other applications are more complex. Let's take, for example, AWS application. It means that you will have to create several environments into AWS with different roles for different departments with permissions on many resources. And maybe it would be a good idea to also deny doing change manually on the web console to everyone, but allow admins to do it via a command line interface by creating, for example, read-only roles. This way, we force the technicians to follow best practices, review the code, analyze, and test things before going live. Regarding the applications, Okta has already thousands of applications pre-configured, ready to test and use in minutes. But sometimes there are some applications or services without these features. So in case you have an application not listed in the repository, you can just create it by clicking a button. Then you will be asked about what kind of application do you want to create. Most of the time, we're going to be dealing with web applications unless you are a mobile developer. Mainly, Okta has four or two different type of applications. Secure web applications, it means that Okta syncs into the application for each user, but these do not prevent users from syncing into application directly, so there's no real single sign-on here. Then you find SAML and OpenID, the most common protocols for authentication we can find on single sign-on, and org2org, which is a kind of bookmark application we can use between two different Okta accounts in a hub-spoke model. Okta offers you also sandbox accounts, so you can test everything before going in live in production. So we can have all those environments, everything we're supposed to have in productions, user accounts, profile information, groups, roles, permissions, and so on, but we don't want to create all those things by hand, right? We're going to use Terraform to do that. I'm going to show you now an example about how to manage multiple Terraform repositories for several AWS environments. Use always remote states. This way we can have a backup in S3 bucket of all the Terraform states. You just can't have teams of technicians working on Terraform with local states. Use also and take advantage of log states. This will prevent collisions or mistakes by locking states and enqueuing them. So only one technician at a time will create, change, or destroy a resource. You can also use Terraform version files to stay in one version and force to work with it in that repository. It will prevent configuration drift caused by change on different versions. I would like to introduce a tool that I like very much, which is called Atlantis, and it's a Terraform pull request automation tool, kind of a unified workflow for collaborating on Terraform through GitHub. This tool is in charge to perform some tests and evaluate if your pull request is compliant with the definition of done in your company or department. Also, the repository code should be as much self-explanatory and organized as possible. Just avoid to have, for example, large directory structures with endless levels of subdirectories. This way, we end up with high performance and resilient Terraform deploying platform. But this is only a small part of our setup. The big picture shows us that we can work with Terraform by using multiple providers, so we can manage all of our AWS environment or many other cloud providers into our organization, and of course, at the same time, we can launch Terraform to build all this from scratch and also integrate it with Okta. It sounds good, right? Let's take a look into the code and let me explain you a few things. For example, in this file, we're creating a lot of resources into AWS, but at the same time, we're referencing some variables to some data coming from Okta provider. And in this case, it's just a metadata application we have to insert in our SAML provider we want to create in AWS. In this other file, we're creating the group rules that will allows us to classify the users automatically depending on the department they belong to. In this case, is one of the user attributes in their profiles. And the other files are just some data sources we need, some application creation, more groups, user accounts, and some scripts and policies that I'm going to show you afterwards. And now it's demo time. We're going to create all the necessary resources on AWS and Okta at the same time in one shot in a really fast way. This is to have all the accounts and departments we're going to create. We're also going to create groups, the group roles to automate user belonging to different applications and some applications also for this demo. So let's see how much time is required to deploy all of this. I'm going to load the access credentials for both providers. And then we're going to launch a Terraform plan just to see how many resources and what resources we're going to create in both providers, in AWS and Okta. As you can see, it's going to create 33 resources, 0 to change, 0 to destroy. I wanted to show you also that we're creating resources in AWS with configuration parameters that we get from the other provider, from Okta. Also here you can see another application configured with OpenID instead of SAML. And we have here all the groups we are creating and also the group roles we define to automate the user group assignment. So let's go to launch our Terraform and see what happens. I'm going to put the time command in front of just to let you know how much time is required to deploy all of this. Usually, if you have a lot of more resources, this is just a demo, it's going to take a little bit more, of course, but it's quite fast. Let's say yes. Now it's creating resources in Okta, in AWS, all our applications. It only took 5 seconds, not bad. Let's take a look into our web console. And as you can see, all the applications we defined has been created successfully. We have 3 Grafana for different 3 environments and also an AWS application we configured. Let's see if it works. Looks like it's logging in. Awesome, we got in. We have access to all the AWS resources we want to manage, and as you can see, I'm logged in with one of the admin roles I previously defined. Let's see if our OpenID application is working. It's just a simple dashboard we configured for this demo. Yeah, we logged in using OpenID. It's also working. Awesome. So as you can see, it's quite easy and fast to create all the resources. Let's go to our admin console so I can show you that all the user accounts have been properly created with all the attributes in their profiles, which is going to make automatically with the group roles that users are being assigned to their proper respective groups and applications. In every of these groups, you can change the parameters by just clicking on the application assigned to that group and modifying the roles and permissions for that user. But keep in mind that Terraform state will be inconsistent. So do the change always in Terraform. And also all the applications we previously configured, as you can see. And coming back to our code, there are a few things that worth to be mentioned about the API. Let's take for example that we need to migrate a whole legacy Okta environment to another one, and we would like to automate the Terraform coding process. So we're going to use Okta API to retrieve some values from an Okta tenant and generate the code in Terraform. To do this, we're going to use some basic bash functions. First of all, we need to retrieve, for example, all the application IDs. We save them on a file to be processed by our next script. With this simple approach, we can generate the most tedious part of organizing people in groups and assign applications to them. As you can see, now we're going to ask to the API to how many groups is related each application, acquiring a relational mapping about how our Terraform code needs to be written. This way, we can use just a simple script to generate our Terraform code. And finally, mention that you can trigger actions on events happening in Okta. If you don't have so much requirements, you can just do that with a few Lambda functions, but if you really need accurate insights, maybe you want to redirect all the events to Alien Vault or Splunk in order to take advantage of artificial intelligence features. As a conclusion, so there is no excuse to not enjoying having a truly automated single sign-on platform in your company. And that's all for today. Thank you for your time and feel free to ask any question if you want. Okay, we have some questions. First question, what happens if Okta goes down? Okta services are available all the time, and as far as I know, they guarantee a 99.9% uptime. So at least they have everything duplicated several times, and probably they're using one or many cloud providers. The thing is that I never had anything down because of Okta failure in the last 3 or 4 years. Next question, is my information secure in Okta? Short answer, yes, your information is secure. Think about Okta protects your information with extensive security measures and controls that are audited by third parties. A lot of customers may need to work with the most high security standards, and that's why Okta needs to accomplish that in order so these customers can be audited too and be compliant with it. Another question, can my admin see my login information? No, the answer is no. Your help desk or even a super administrator can see your username, your profile information. They can disable or change, even reset your access credentials, but he or she does not have access to your password. Actually, it's not even possible to be retrieved through the API. It's just not possible. Talking about AWS, it's possible for a user or a group to have access to more than one role at a time. Yes, you can configure a user or a group with all the roles you want to be assumed in AWS. I actually remember having a user with access to almost 40 different roles in more than 23 AWS accounts, and everything was fine. Probably there's a limit on AWS, but I never reached it. I hope you enjoyed the talk. We're gonna answer the remaining questions by email, so feel free to ask anything you want. Thank you.